It is on. It's not on. Not on yet. I can hear myself. Okay. So this would have been a much easier circuit to simulate. Okay, let's do the reverse. Let's do the reverse for a change. That's my electrical circuit. Convert into its mechanical counterpart. And electronics engineers are going, if it's already in electrical world, why going back? What is this? Oh, the electrical equivalent. May I just? So this is the thing with mechanical forces. You need something to move from, right? Yeah, good. There's still scope in Deutsche Bank. Oh, you have put this thingy as well. Good. It's not, but there is no equation here which shows how it is moving to the ground, right? So it looks nice, but yeah. So this is relatively easy. Most of you have got it. Well done. Okay, so a number of you would have got something like this. Okay, stiffness to mass, and then stiffness and a damper to another mass. Good. Before I start doing something more serious, or one more problem, why don't we take this perceptron? Let's just assume it has got 2 inputs and known outputs. Can you guys train it? Remember what we did in training? We basically said that for the given set of inputs P1, that's my expected output. For P2, that's my expected output. Okay? So it's a 2 input system. It will have 2 weights. I need to find the weights and biases B. So start with weights being random. So there are 2 numbers. You can only pick 0, 1, 0.5, 1.5 something, and then see if it converges. So any luck? I'll just break for a second and then I'll bring it back again here. Okay, while we do this, let's do some quiz type questions. Okay. What makes a neural network deep? Again, can I hear?
Hidden layers.
Layers in plural. Wrong answer.
Connectivity of more layers.
Nana. Look at my word which I said. Layers in plural. A single layer is enough to make it. Okay. Why are MEMS? Oh, you guys were not there at MEMS census, right? Now, one at a time, can people give me some example of activation function? What is the kind of activation function we have used today? Sorry? We used a hard limiter, right? It was a hard limit. We used a simple function below other. Anything else you guys have? What are the functions? We saw functions which look like this. So what will be the mathematical counterparts of these? Tan H, hyperbolic tan, right? Sigmoid, what else? Ramp in a good day, yes. There are also functions like ReLU, which some of you might have come across, rectified linear units. Okay. Now, I know we have limited time, so on the same folder where we tried putting our images the other day, what I have now done is, and I'd rather do it, just give me a second. Okay, so you will be getting most of my lecture slides as printout, but on the same folder I have also placed a collection of book for you guys. Okay, now because the network is slow, I will just show you what is there in the book. The book contains, let's say, 130 odd page book. You don't have to read all of this, but I have given 2 book chapters which I wrote. The fixed pattern noise is my article in the Encyclopedia of Optical Engineering, and then there is another book chapter on CMOS sensors for wide dynamic range imaging. Okay, if I will also put another book chapter which we wrote on advances on digital imaging. So it covers the whole theory which we have discussed in more details in case you are interested in further studying. After that, I've put some review articles There's one review article on temperature sensor. I know we have not covered temperature sensors till now, but we will cover this before I go away. This basically, it's a very good article which covers, oh sorry, there's only one page. Okay, I'll put all of it articles soon. And there's also a review article on microbolometer type infrared detectors. So temperature sensors can come as waveform detectors as well as heat detectors. We'll have a look on these. And then there is an article on chemical sensors, primarily pH. Ooh, that's where temperature, the second part of temperature sensor is. Okay, so it talks about various circuitries which are used in temperature sensor as well as the type of sensors to be built there. There is one tutorial article on ISFET arrays. These are the ones which can be used for measuring pH in solution. Okay, so I will be discussing the theory in the classroom, but it's only a 2-hour theory discussion anyway. So this entire book will be there for you to download, keep it for free, and do whatever you want after that. Okay, so that will be available for free for you guys, and of course all the lecture slides and everything is available as well. The books do have copyright, and so have the articles. I'm giving them just as educational material. They should not be used commercially. I guess you already know the rules of regulations. Please also don't plagiarize things from there. If you want to use it, just cite the book and that will be perfectly fine. Okay. I will also be putting all these tutorials. I have the many number of other questions which we have. So part of this course is helping me draft a book on microelectronic sensors, as I said in the beginning. So each one of these sessions is becoming part of my manuscript. I also did another Gyan course in Rourkela where we are writing a book on financial engineering, so application of engineering in finance. So I'm hoping someday I will have enough energy to finish both of my books and then I will go to sleep. Good, it's almost 5 o'clock. I know we were a bit slow in tutorials, but then that's what happens when we are working on it. We will stop now and we will join again tomorrow at the same time at 9:30. And for those of you who are interested, so what am I planning to do tomorrow? Let me just have a quick look. So tomorrow we will cover temperature sensor, infrared sensors and temperature sensors. Okay. Part of this is, so infrared sensors are one of the strangest creatures. They have been built from Second World War onwards, right? They're also the ones which the defense industry demands the most and restricts the most. So I will not be able to talk to you everything about infrared sensor. Remember, I come from Europe where I have got export control restrictions on what I can tell you. But we will tell you normal coverage, particularly in most normal applications. But as they are used to find heat, and there are things like heat-seeking missiles or heat-seeking geolocation, much of this is restricted. Even though there is a lot of application in biomedical world. So people got accustomed to infrared sensors during COVID times when you had remote temperature measurement. So we'll look into how these sensors are made, what is done. We'll again be doing a cursory tour. We'll not go as deep as we went to camera pixels. So in the second half of the day we will do that. In the first half of the day we will do the labs. Okay? Any questions? If not, have fun. It's Wednesday. What's the worst could happen today? do a bit of PR for my stuff. So you guys heard I'm a professor at Siegen, which is a place in Germany. It's about an hour from Frankfurt, an hour from Cologne. It's and before Siegen, I have served in Oxford and in Glasgow in UK. So this is where we are in the map of Germany. So that's the province of North Rhine-Westphalia, and this region is known as the Ruhrgebiet. Düsseldorf, Dortmund. So this area has been the historic industrial heartland of Germany. Oh, do you want to talk for me? So if you want to talk, talk it safely so that I don't hear you guys. Okay? And we are in Siegen. That's a tiny little protruding area here. It was a historic iron and steel city. We claim that iron and steel industry started in Siegen. Okay? But now it has grown up from what used to be these to loads of German firms. As you know, Germany is fairly industrialized nation, and the industrial capacity is fairly well distributed across. However, our history, is there anyone who is interested in painting here? No one does painting, is it? So our history is more famous by our more famous son, Peter Paul Rubens, who was born in Siegen, and then he moved to Antwerp, where he became a painter, very fairly famous painter. The story is very interesting how he was born, and maybe this will caught your attention. So his father was having an affair with the lady of the castle, aka, the duke's wife. And that's when the duke got this idea, and he put his father in jail. While his father was in jail, Rubens was born, and when the father got released of jail, he was kicked out of the province. Before German reunification, Germany used to be many small kingdoms. So Rubens didn't spend much time in Siegen, but of course he was born there, so we still claim him to be ours. That's the university. We are a comparatively new university by German standards. We were only established in 1972. But we are fairly large. We have about 18,000 students. We are a comprehensive university in Germany. Many other universities you will see would be either a technical university or a standard university. We are one of the few which does technology as well as theology in the same university. We have roughly 250 professors. So professors in Germany mean people who head a research institute. Okay. And about 2,000 staff members. So I belong to faculty 4, which is our science and engineering faculty. So Siegen is a very hilly town. It's also a very green town. So each faculty gets its own hill. So if you want to go from engineering to sciences, you have to go down the valley, cross the road, and then go up the valley again. Little wonder I never go to science faculty. You would have realized by now I'm not very exercise doing person anymore. We have got 6 departments here, including sciences, and electrical and information engineering is one department. That will be a joint department, what you will call here electrical, electronics, and computer science. Okay. In electrical and information engineering, we have about 1,500 students. These numbers fluctuates from year to year, but that's our bachelor number, that's our master number. So we do a 3-year bachelor program. We have about 110 scientific and teaching staff members with 22 heads of institutes, and about 50 technical and administrative staff members. We are a comparatively smaller university compared to our other bigger counterparts, so we are specializing in the field of sensors. That's our bread and butter. We host the German Research Council Advanced Research Center for AI and Sensors. And our main area of the research will be micro and nano electronics, optoelectronics, and computer science, primarily embedded system, visual computing, and machine learning. We do 3 masters, international masters. International masters mean they are taught in English. Electrical engineering is entirely in English now. We have got electronics design, which contains things like microelectronics, VLSI design, and optoelectronics. We do a master's in communication engineering, and our mechatronics master's with it jointly with mechanical engineering has been running for a long period of time. It's a very popular master's degree. We also do a 3-university master degree on embedded system with nanoelectronics. This is with Portugal, Greece, Zegan, and Latvia, and you get to spend 6 months in each one of these countries in order to do masters. This is also a masters where you get paid to do masters, so but it's highly competitive to get into. So we have about 30 seats, but you get very well paid to do that. So that's Zegan. A bit of imaging history. Zegan has been a very strong imaging history. That's my predecessor, Professor Marcus Broom's chair, which led to the formation of Silicon Vision camera company. It used to make amorphous silicon company. The one with Professor Rudolf Schwarze, his 3D time-of-flight spin out is PMT, and that's a very successful company. So if you buy things like 3D camera on Lenovo phones, they are all made in Zegan. So we do quite a lot of 3D imaging work in Zegan. Bit about my chair. We established in 2018, and my institute works on analog VLSI, microelectromechanical systems, image sensors, and we currently have about, well, that's a bit oldish number, we have about 17 PhD students with us. You came to know what I did. I did my Bachelor of Technology from this place, REC Warangal. Then I went and did my doctorate from Oxford. I primarily research on analog camera, and digital camera is my bread and butter. For a long time I used to make digital cameras. These days we also do a bit on AI in virtual world, business world. So some of my past research, we were able to identify the site of cortical prediction in human brain. So to some extent, so let me explain how this thing works. This is one of the more interesting work which we have done. So we see from 2 eyes, right? Can you see from 1 eye? Okay, so I will see if I have got the slides. We'll do an experiment to see how good you guys can see from 1 eye. Okay? Anybody has any objection to doing experiments with their eyes? Good. Then let me find this thing for you guys.